Welcome to O-Level Physics Online. In this video, I'll be talking about calculation involving electromotive force, terminal voltage, and lost voltage. And what you'll be able to learn at the end of this lesson by the end of this lesson, you will be able to analyze calculation problems involving electromotive force, terminal potential difference, lost voltage, as well as internal resistance. Also, you should be able to solve a calculation problem on electromotive force, terminal potential difference, lost voltage, as well as internal resistance. However, if you can recall from what we have done in the previous video, we've stated the relationship between electromotive force, terminal potential difference, as well as lost voltage. Also, we stated the formula for V big R, which is terminal voltage as IR, and the formula for lost voltage as V small r equals to IR. Also, by substituting V and small r based on what you have done before into the first equation, we'll arrive at what I'm having in this place. And making I the subject of the formula, or expressing I in terms of E, R, and small r, you have them to be like this. And rearranging the first equation after substitution of V equals to IR here, we can arrive at V small r equals to E minus IR. This is the basic thing that we'll talk about in the previous video. However, the following two key points must be noted when you are solving calculation problem under current electricity generally, or under electromotive force that we'll be talking calculation on electromotive force that we'll be talking about in this video. So the first point that you must know is that when you are having series arrangement of resistor, the same amount of current will flow through each resistor that you have, while different potential difference will drop across each one of them, depending on the size of the resistor that you are having. Also, if you are having parallel arrangement, the same voltage will drop. Unlike the first one where different voltages will drop, for this one, the same voltage will drop across each resistor, while this different current will flow through each one of them. Different current will flow through each one of them. It's a very vital point that I must know, which I'll be referring to while solving the calculation problem we have under this topic. So let's go and look at the next question, the first question I will have on this. The first question I'm having here is the terminal potential difference. The terminal potential difference of a cell is 3 volts when it is not connected to any circuit. Meaning when any load is connected to it, when it is open circuit, the terminal PD is 3 volts. Then when no current is flowing. So when the cell is connected to a circuit and a current of 0.37 amp is flowing, the terminal potential difference falls to 2.8 volts. What is the internal resistance? That's what you are required to find in this question. What is the internal resistance? That is what you are required to find in this question. So to understand this one, let's take it one after the other. The potential difference across the terminal of a cell is 3 volts when it is not connected to a circuit. So that shows that no current is flowing. So this is a very key point that we need to take note here. One, when it is not connected to any circuit and no current is flowing. And remember, from what you have mentioned in the previous explanation, what I mentioned is that when no current is flowing, the EMF you are measuring in that case, when no current is flowing or when you are having open circuits, what you are having, the voltage you are having in that case is what we refer to as EMF, meaning that electromotive force we have in this question equals to 3 volts. Then it is mentioned in the question that the current flowing here is what? 0.37 ampere. So we have I equals to 0.37 ampere. And the last point we have is what? The terminal potential difference. This one is spelled out in the question that the terminal PD, which same thing as big V, is same thing as 2.8 volt, and we are required to calculate internal resistance. These are the data given to us, and this is what we are required to find in the question. Now, to solve this, the next thing we have to look into now is that recall from the previous equation that I mentioned earlier. We know that electromotive force E equals to what? Terminal PD V big R plus lost voltage same thing as V small r. So if you're merely looking at this, what we are looking for is not there. The R I'm having in this case is just indicating the internal resistance, showing that voltage across internal resistance. That doesn't mean that we're having V multiplied by small r, meaning I'm just having V subscript r, not the relationship between them. Now the next meaning that R is not the real value of internal resistance. It's just indicating that we are having lost voltage in that case. Now the next thing we have to look into now is, remember that we have a formula that contains V equals to IR, meaning V small r I'm having equals to what? I multiplied by small r. So by substituting this one into the equation I'm having here, automatically I'm going to have V equals to E equals to V big R plus IR. But without knowing the value of this equation, without knowing the value of V, it will be difficult for me to get the value of small r. I is known in this equation, correct? Okay. The value of this I is known in this equation. The value of VR is known in the is not known in the question. So I need to get the value of this V big R before I'm going to start solving the question. So let's move on. So from this now, I can get the value of V small r to be equals to 3 minus 2.8. 3 minus 2.8 volts. That's what I'm going to have in this question. So from this, the next thing I'm going to have is going to be V small r equals to 0.2 volt. Then the next thing I'm having is going to be what now? By substituting in this equation, I'm going to have V small r equals to IR. Then from here, I can make R the subject of the formula, which will give me that V as R equals to V small r over I. And substituting the value, since we have gotten the value of V small r to be equal to 0.2, I can just put into this equation. Then we've known the value of current to be equal to 0.37 in the question, which I stated here as well. And that will give me the value of R to be equal to 0.2 divided by 0.37. So using your calculator for this, you get the value of internal resistance to be equivalent to 0.54 ohms. That's what you're required to do in the first question. The next question we have here is calculate the terminal potential difference, and lost voltage across 20 ohm resistor connected to the battery of electromotive force 15 volt and internal resistance 5 ohms. So to solve this question, what are the parameters given to us in the question? The first one, we have to the battery of EMF. EMF is spelled out in this question. We have E equals to 15 volts, so E equals to 15 volts in the question. And we have the external load. The external load given to us here is 20 ohms because that is what is connected to the battery. So we have R, big R in the question, the same thing as 20 ohms. And we have internal resistance is mentioned as well in the question as what? 5 ohms. These are the parameters, all the parameters given to us in the question. And we are required to calculate the terminal potential difference, which is V big R, and the lost voltage, which is same thing as what? V small r. These are the two things we are required to find in the question. But remember that terminal potential difference is equals to what? V, big V equals to IR. R is known, but we don't know the value of current. Also, the value of lost voltage, small v, is same thing as what? I multiplied by small r, but we don't know the value of current as well, which shows that we need to get the value of current before we can proceed to solve anything we have in this question. So how do we get the value of current in this case? Remember this equation I stated earlier that I equals to E over R plus small r. So from this now we can get the value of current. So just substitute the value of electromotive force given in the question, which is 15 volt, divided by big R, the same thing as 20 ohms. That is what I'm having in this case. Then we have plus internal resistance, which is same thing as 5. So simplifying this one, you are going to have the value of I to be same thing as 0.6 ampere. And from this, we can now get the value of our terminal potential difference by simply substituting the value in the question, by simply what? Substituting the value in the question. So by simply substituting the value in the question. So substituting the value of this one in the question now, that will give us the value of this one to be the same thing as what now? 0.6 multiplied by 20, which will give me 12 volts. To give me 12 volts. And the next thing I'm having is what? To get the value of the lost voltage. How do I get the value of the lost voltage? Lost voltage is same thing as V equals to IR. Then I can substitute the value of I, which is same thing as 0.6. Then multiply by 3, multiply by what? Multiply by internal resistance, which is same thing as 5 ohms. And that will give us 0.6 multiplied by 5, and that's same thing as 3 volts. So these are the two parameters we are required to calculate in this question. Then the next question we have is, which is solve problem 3, 2 cells. This is a very, very important question because the techniques we are going to use in solving this question will be different from the way I solved the first two previous questions. 2 cells, each of EMF 1.5 volt and internal resistance 2 ohms are connected in parallel. This is one key point that we need to take note here. Now calculate the current flowing when the cells are connected to a 1 ohm resistor. Now, merely looking at this question, we have 2 cells, each of EMF, that is for each of the cells that we have, they have EMF of what? The first one has EMF of 1.5 volt, the second one has EMF of 1.5 volt. Also, the first one has internal resistance of 2 ohms, the second one has EMF of what? Of internal resistance 2 ohms. Now, the next thing we have to do is just set out the parameter. So that's so that for the first cell, the EMF of it is 1.5 volt. The second cell is EMF of it is 1.5 volt. But the question now is that, are we going to add two of them together, or we are going to subtract them, or we are going to leave them? Of course, to understand this concept, remember the condition I stated earlier, that if you're having a series and parallel arrangement, the same voltage is going to be there. Meaning that if you are even having 10 EMF, in that case, you are just going to pick one because it's just the same value you have for them throughout. Just that though the value will be stronger, but you are going to just pick one of them to represent them. So we are just going to use EMF to be equal to 1.5 volts. We will not add them together because they are in parallel. Then the next thing we have is internal resistance. We are having internal resistance. The first one is 2 ohms. The second one is what? Is 2 ohms. Then we have external load to be equal to 1 ohms. And because they are in parallel, we need to get the effective or net or total internal resistance that we have in this case. And remember, if we are having internal resistance to be in parallel, the simple formula we usually have is what? Product over sum. Product over sum. So what you just do in that case is what? 2 multiplied by 2 divided by 2 plus 2, because they are in parallel. You multiply them, then you sum them together. But if they are 3 or 4 in number, then remember you are going to use something totally different, and that's going to be 1 over R total equals to what? 1 over R1, 1 over R1 plus 1 over R2 plus 1 over R2 divide sorry, this because I'm using mouse, that's why it's not that strong. Then we have plus 1 over R3 and so on like that. If you are having more than one, because we are just having two, you can make use of this formula. Then at the end you are going to make R total the subject of the formula. Now from what we are having in this case, now we need to get the value of current. That's what you're required to find in the question. We can't get current direct unless we resolve the problem we are having here. So my R total in this case now will give me 1 ohms. Then I can now get the value of my current using the relation I equals to E over R plus small r. And simplifying this one, we are going to have E, which is 1.5 as given in the question, then divided by R, and R is what? 1. Then we have plus lost internal resistance, and that's going to be what? Internal resistance is 1 rather, while the external load equals to the value of R in this case is supposed to 2 times 2, 4 divided by 2 by 2, 2 plus that will give me 1. This one's supposed to be 2. Please note this correction. This is going to supposed to be 2. So we are going to have the value of this one to be the same thing as 2 plus 1. And at the end, I'm going to have the value of current to be 1.5 divided by 3, which will give me 0.5 ampere. Now, key points that I want you to just notice here is that the first correction I made here, the value of my external load, big R, is same thing as 2, not 1. So that's why I'm having 2 in this case. Now, another point is that because we are having parallel arrangement, automatically you're just going to pick one of the voltages. You're not going to you will not add them together, and you're not going to subtract them. You just pick one because we have parallel arrangement. And the next question is going to clarify the points I'm trying to explain in this case. So the question 4, what I'm having in this case is that two cells, just like the previous one, each of EMF 1.5 volts and internal resistance 2 ohms are connected in series. Calculate the current flowing when the cells are connected to what? To a 1 ohm resistor, to a 1 ohm resistor. Now to solve this question again, let's look at what I'm having here. We're having the EMF in this case, they are 2 in number because they are in series. I need to spell out the value I'm having here. The E1 is 1.5 volts, while E2 is going to be 1.5 volts because they are in series. And remember I said if you're having series arrangement, what I mean by series arrangement is the first cell is like this, the second one is arranged next to it like this. That's what's referred to as series arrangement. So if you're having series arrangement, this is my cells now in series. So what you just have to do in this case is that E1 and E2, because they're in series, you just add 2 of them together for you to get the value of net value of the voltage that we are having. Now the next one we have is what? Internal resistance is what? The first one is R1 is 2 ohms, this R2 equals to what? 2 ohms as well. I'm having external load here to be equals to 1 ohm resistor. Now to get we are looking for the value of current. Current is unknown. So to get the value of current, we need to get the value of, So to get the value of current in this case, to get the value of current, we need to get the value of net electromotive force because they are in series. Unlike the previous one, remember in the previous one, we just pick one because they are connected in parallel. But for this one, we are going to add 2 of them together for us to get the net value of the voltage I'm having in the question. And to get this one, my E total is going to be E1 plus E2, and that will give me 3 volts. Why for the other one, I'm laying emphasis on it. For the other one, we just pick one to represent the 2 of them because they are in parallel. Then the next thing we have is what? We need to get the value of R total in this case. To get the value of R total, That is total internal resistance in this question. All the thing you just have to make use of in this question is just going to be what now? Because they're in series, you just add two of them together. Because if you're having resistor in series, you just sum everything together to get the value of net resistance or total resistance or effective resistance. And that's how I got this one to be equals to 4 ohms. Then we can make use of our formula I equals to E over R plus R, and that will simply give me 3 over 1 plus 4. And that will simply give me 3 over 5, which is same thing as 0.6 ampere. So if you compare the solution I'm having here, the answer I'm having in this one to the previous one, for the previous one, the E total will just pick one. When you're having a series arrangement, you will add two of them together to get the net value of what electromotive force, and that's what you're required to do in this question. And the last question I'm having here, is calculate the effective EMF, effective internal resistance, and total current we have in the circuit. That's what you're required to do in this question. Now, merely looking at this question, it appears as this cell is there in series. But what you notice here is that the positive pole of this one is connected to the positive pole of this one. Unlike the previous one, we would have considered this one to be series. To get the value of net EMF in this case, we would have just added the two together. But because the positive is connected to the positive, so we can't just assume they are in series arrangement. Because for series arrangement, this is how the normal series arrangement of the cell used to look like. The positive of the negative of this one, the negative pole, which is the shorter line, is connected to the what? To the positive. That's what we consider to be what? The series arrangement. But for this one, positive is connected to the positive, negative is connected to the negative. So to get the value of effective EMF in this question, all you have to do in this case, all you have to do in this case is that because they are in what? Because they are in series, but their polarity, they are in opposite direction to each other. What you just do in that case is what you need to subtract them from each other to get the value of net EMF. So to get the value of net EMF in this case now, you are going to just subtract the bigger one, smaller one from the bigger one, and that's going to be 2 minus 1.5 volts. That will give me 0.5 volt. Then the next one is to get the value of R total. To get the value of R total in this case, to get the value of R total in this case, all you just have to look into is what? Because they are in series. If you look at this one, they are in series. So your R total is going to be R1 plus R2. That will give me 4 ohms. And that is the second thing we are required to get. That is effective external resistance. Then the next thing we are required to get is what? We are required to get the value of current. To get the value of current, we use the normal relation that we have used in the previous two questions. Then that's going to be I equals to E over R plus R. And that will simply give me what? 0.5 divided by 10 plus 4. And that will simply give me 0.0036 ampere. And that's what we are required to find in this one. These are the simple calculation problem that we have, which are assumed to be simple. So to understand this topic very well, try as much as possible to solve as many questions as possible. Check your WAEC or NECO or UTME or IGCSE past question and solve more questions there. If you have any challenging problem you have on the topic, don't forget to post it in the comment section or send it to my mail and by checking my info that we're having.